All right, so now we are ready for a different class of problems right here. And so once again, given that we are on a standard normal distribution, it's an n0, 1, and that nice bell curve with center at 0 and sigma 1 right here. And here's the worded question here. I want to find the cutoff z-score, and because any z-score, any value on this horizontal axis here is a z-score, so let's get straight to the point here. Let's find the cutoff z-score of the, and here what I'm looking at here, I'm going to write it in capital letter right here, but of the bottom, about 95%. And so let's not take it too far yet. Let's try to understand this description here graphically. So it's a cutoff z-score, meaning so any z-score on this line right here, remember if we're shading the entire area inside our normal distribution curve right here, then it's a total area 1, or the cumulative probability inside the bell curve. But so if we pick any z-score, then we can create a cutoff. And that's what it is. It cuts the area into two parts. And so now further into the description, we want that cutoff to be the cutoff z-score of the bottom 95%. So meaning the requirements we're looking for about this z is that we have to find where we put that cutoff so that to the left-hand side it has 95% of data. So 95% of data is required to be to the left-hand side of that cutoff. That's what it is. That's what the description is putting up that requirement right here for us. And so, and that's our plan. So now, the further impact here is that this z being the cutoff of the bottom 95% right here, then we have to understand that we already had the left area. So the left area, or the area left of z, of this unknown z right here, is already been given, being, and in decimal, highly recommended, 0.95. And so this left area now, so in this problem, we are actually not looking for area. We already had the area, and here specifically it's the area to the left of that z-score right here. And now with that area to the left of z-score given to be 0.95, I'm asking for what z-score value is that? So where do we put the z-score on this line so that it takes 95% of area to the left-hand side? And so in that argument, quite simple. And once the area has already been converted into a left area, so very important that you have to put your area, you have to interpret your area here as a left area, the area to the left side of your cutoff. Then, and by the way, I'm putting things in a box here, just indicating it's an emphasized point. It's not the final answer yet. So with your, among the programs I made, I put in the same Microsoft Excel file that I call programs right here. But if we're looking down to the bottom tab right here, and I'm going to have another click into the other tab that's called INVZ. This program here is meant to, I wrote this little program to, see, INV stands for invert. So we're inverting an area. So what we have here is an area. We're going to invert that area to come back and find out a z-score. Just perfectly suitable for this kind of problem. So, and it's already there. So if left area is being 0.95 as given in the problem, so all we have to do now is to run the technology. And like I said again, INVZ program here is the program that I wrote. But once you understand the purpose of this program, what its function is for, then there are plenty of programs out there over the web or on the market that allows you to do this kind of problem. The idea here is that we're inverting an area on to the left of a z-score to find out what z-score that is. So along with what I said, allow me to show everyone how to use the TI-83 or 84 calculator to handle the very similar work. So once again, what we're looking for here is we're looking for a z-score that has the given area shaded to the left. And so I'm currently using an emulation software program that works, that demos the TI-84 Plus Silver Edition. But it should work exactly the same with all TI-83 and 84 calculators. So to get there, to find the program that does a similar work as the INVZ program, I am going to hit second variables on the TI-83 or 84 calculator. We are going to scroll down to option number 3 under distribution programs here, and then hit enter to select that particular program. So I need to point out one thing to be careful for everybody, that for the TI-83 calculators and some of the earlier versions of the TI-84, users won't see this menu right here. This menu is more for the most recent versions of the TI-84 Plus calculators. If you are running a TI-83 calculator or a TI-84 earlier TI-84 calculator, then right after selecting INV norm from second variables, then you are taken directly to this command being printed on your home screen right here with a blinking cursor, with an opening parentheses and a blinking cursor here. And now allow me to get back on my actual software program that I'm about to use, because users of all versions of the TI-83 and 84 calculators must know how to operate with your machine properly. So now back on the newest version of the TI-84 Plus, then in this menu, the area that the calculator is asking for is the value 0.95, because this is our given area being shaded to the left-hand side of our designated z-score, the z-score that we're looking for right now. So, and here we want to default these two values to 0 and 1. So mu, we're going to give it 0, and sigma, we're going to leave it 1, just whatever being the default here. So I'm going to hit enter and a couple more times, and then when it's blinking at pace right here, I'm going to hit enter one more time. And so now you can see that even on the newer versions of the TI-84 Plus calculators, then eventually you're also going to be taken back to the command. And so this way, how we're looking at the command right here, TI-83 and 84 users, all you have to do now is just simply type in, once you're at that command, then all you do now is just type in the area that you're given. Next, it comes a comma, and then the 0 as you've seen in the menu, and with another comma, and then we type in a 1. And then we close it, the parentheses. And now we are ready for getting our actual answer. So after finishing our command here with a closing parentheses, now we can hit enter. And so the calculation now shows the results for us. This result here will be the z-score that has precisely 0.95 area shaded to the left. And 0.95 here is equivalent to a 95% of area on that standard normal distribution bell curve shaded to the left of this found z-score. And this answer now, if we're looking back at what I've shown earlier with my own INVZ program, it is going to be exactly the same. And so here, once we run that program, then we imply that. And so let me just simply indicate it. If I'm using my INVZ program here, then I'm inverting, I'm treating that as a function, as a program, then I'm taking the given value 0.95 as an area. So area goes here. Okay, and so that z-score comes out to be, so now our final z-score here is being 1.6485 and a lot longer. And once again, I'm leaving the rounding here quite open. And be ready that any of your assignments, either you're using a web assignment or you're using a textbook assignment, watch out for different rounding requirements they being asked for coming out with your final z-score. And so before I'm closing down this kind of problem right here, let me emphasize one thing. So this same z-score, in the way how it's worded, it's being asked as it's a cutoff. So fundamentally, yes, it is the cutoff because it's the entire area of your bell curve. Now, from wherever you put your z, but from where it stands right here, it cuts the area into two different portions. So, and the one portion here we're looking at is to the left-hand side. And so that's why it's named bottom 95%. But see, the same, and let me branch out a little bit, the same cutoff, the same exact location, but sometimes the same problem can be also regarded as, because it's just the way how area is. This is also aka known as it's the cutoff, okay, aka the cutoff z-score of the, but here instead of saying bottom, I'm looking at the top. But see, from where it stands right here, then, and top here means what? Think about it. It makes sense to be those above it, right? So above here is indicating to the right-hand side. So from where that z stands, same spot, same value, 1.64485. But if we look, we can also look at that in terms of the, as a cutoff z-score of the top, what? The top 5%. Because it has been already 95% here, and I should have labeled that as when we begin the problem here, but 95% is here, so it makes sense that this is the remaining 5%. So it's also the same. This value we just found, z-score equals 1.64485. We call that the cutoff z-score of the bottom 95%, but here it's also known as the cutoff z-score of the top 5%. And really, if the problem was worded as finding the cutoff z-score of the top 5%, same z-score ultimately that what we need to get, but instead of being asked as a bottom 95, if the problem was worded as asking for the top 5%, then your first big responsibility is, once again, and that was the reason why I put this step right here, finding the left area of z, and I put that in a box right here, because your first big step here is to figure out from where your cutoff is, how much left area of z is that. But here we have to do a little bit of math. Simply just, that's all. So 100% is full curve, and we're taking away the 5%. And here I'm pretending like we are doing some separate work completely. But see, if our same z-score here, but defining the top 5%, then the left side of that has to be subtracting 5% from 100%, and we're ending up with, once again, that bottom area or the left area of z has to be 95%, or in decimals, ready for the INVZ program or ready for any technological resource to calculate, and we use a 0.95 as the most popular expression of that. And then once we got that left area nailed down right there, then you can either run my INVZ program if you have a copy of that, or you can just simply use any web resource that has the same similar functionality, inverting an area to the left of a z-score back to a z-score, and you should end up with this. And so I do plan to give out another problem similar along this line right here. So how about let's call this problem here part A right here. But the whole generality of this kind of problem is that we already have area given. We're not looking for area. We're looking for which z-score value defines how much area there to the left. And again, on that standard normal distribution curve, that nice bell curve would center at 0 and sigma 1 right here. The next question I want to asked. Quite similar with question A, but here let's watch out for a little bit extra details right here. But I want to find the cutoff z-score again, but here this time cutoff z-scores of the, and the description I'm putting in now is the middle, about 80%. All right. And so we're still looking for cutoff z-score. But notice this time I'm using plural for z-score. It's cutoff z-scores. And here my description of the area here we're having is a middle 80%. So think about the graphical explanation of this middle 80% on this bell curve is this. So middle means we have to try, and it doesn't have to be precise, just put it down two z-scores that are symmetric from each other. Just simply put down two z-scores that are equal distance from each other. And from where they are, they create an area that's located exactly in the middle. And that's what the middle 80% is all about. And so, of course, we can't really make it precisely how big is 80, but just label that this is 80%. And so what we're looking for here is that what two z-score, and how about here in this problem, I'm going to namely call them the z1 and z2. So the low z-score is z1, the high z-score is z2. But these two z-scores, z1 and z2, define or trap my middle area inside of that. And that middle area is given to be 80%. And so here in this problem, then we strictly have to stay with that fundamental I pointed out earlier when we begin studying the standard normal distribution, that any z-score, doesn't matter if you know it or you don't know it, but any z-score from where it stands, there will be an area shaded to the left-hand side. So meaning from where this z1 here is, so from where that z1 is, there is a left area shaded to the left. Or from where this z2 is, there will also be a left area shaded to the left-hand side. I don't want to interfere with the picture in black right here, but now I'm going to draw an arrow indicating cumulatively from where z2 is. Cumulatively from where z2 is. We can have also another left area cumulatively shaded from where z2 and completely shaded inside the curve and shaded all the way to the left. So any z-score has an area to the left, cumulatively. And so at this point, I have to admit, we have two separate choices, two separate independent choices. We can independently choose z1 to work out first, or you can choose z2 to work out first. But here's just a little bit of my own experience, but z1, the lower, is a little more direct for me in terms of figuring out. Because the plan here is that we need to figure out how big that area of the left-hand side of z1. Now notice, the given area here is neither the left area of z1 nor the left area of z2. It's the area in the middle. And so, but here's how it works out. Full curve, full complete accumulated area inside a curve is 100%, as the rule we always know. And so I'm going to take away the middle area. So imagine the entire curve right here. If I just simply take out that middle area, then we're going to have the left behind, after the subtraction, these two areas. And then now simply and taking full advantage of your curve being a nice symmetric curve right here, having the two sides equally divided right around that center, then I'm going to take that remains amount. And by the way, 100 minus 80 is already a 20% left. But that contains this one tail on the left and this other tail on the right-hand side. So now I'm going to divide that subtraction, that difference, by 2. Just indicating that we're cutting it in half right here. And this amount right here, calculation shows it's 10%. But this truly is our left area. This is left area, but to be a little more specifically of Z1. Okay, and that's the way how we can find left area of Z1, and I have to underline because it's just I purposely chose to start out with Z1 simply because it has a little bit less step for us, and the area can be seen a little more direct right here. Whereas the area to the left hand side of Z2, we have to do a different trick. And so now our left area, and we already got our goal, the big goal here, we found the left area to one of our Z-score. And now in decimal, this is 0.1. So we got some left area. And so now in that way, so the next step now is to invert that area, that given area, into a Z-score. And once that Z-score comes out, it will be that Z-score for our lower Z-score, Z1 right here. And so I'm using my own INVZ program, but really any viewer for this video can use any other technological resource over the web or any online tools that you can find. But so I'm going to run my INVZ program, and I'm providing 0.1 as the given left area. So my value coming out of this program is projectedly or expectedly my Z1 value, my Z-score 1, the low end right here. And so here's my Z-score. So back into my INVZ program, now I'm going to go ahead and enter 0.1. And on the TI-83 or 84 calculators, we can achieve the exact result. Once again, by going second variables, select option number 3, hit enter, and again I need to remind TI-83 or some users for the earlier TI-84 calculators that after you select inverse norm, you will be taken directly to a command like this, being printed directly on your home screen with an open parentheses and a blinking cursor. And now we are going to enter, this time our area shaded to the left of Z1 is 0.1. And again, we want to leave these two values defaulted to be 0 and 1. So I'm going to hit enter a couple more times. And if you have to type in the command, 0.1 is the area shaded to the left of our designated Z-score that we're looking for, with a comma. Type 0 with a comma, type 1 for sigma, close the parentheses. And now we are ready for executing this program or this command by hitting enter. And that is now the exact result, as we have seen how I obtained that through my developed INVZ program. And so the Z-score we're looking at now is being negative 1.2815516. Okay, so we found one of them. Because remember, the question was asking for finding the cutoff Z-score. We found one. We found the cutoff. Here has to stand at Z1 must be at a negative 1.2815516. And then how far to round, it pretty much depends on every different assignment problem. So I'm not going to be too precise about how far we round. I'm not going to be too specific about how far to round. Let's just leave the answer like that. And so here's the thing, finding Z2, and like I said, every Z-score has an area to the left, so technically speaking, we have to reinvent all that, finding the area to the left of Z2, and then run some kind of technology. Here I'm using my INVZ, but you can have some other technology to invert or to reverse the area and it shouldn't even be 0.1, just to reverse the left area of Z2 into the actual value where Z2 stands, and that's the idea right here. But actually, so it seems like that's a lot of work waiting ahead, or the other half of work is still waiting for us. But as a matter of fact, if we take a closer observation of the relationship between Z1 and Z2 here, It's just the way how the bell curve is, and that's why, you know, it's for years it's always been a fascinating thing for many statisticians to study the bell curve, and especially the standard normal distribution curve right here. But once we know that our area is the middle area, it's just the way it is on this bell curve, then Z1 and Z2 must be exactly opposite sign. Opposite sign. So here's, from that powerful understanding, we already found Z1, didn't we? So Z2, the simple trick right here, flip the sign of that. So the sign now is going to become positive 1.2815516. And we found the answer. And that's how we find so now that's the low cutoff of this middle 80% area. This is the high cutoff, z-score, of the middle 80% area. So what we did here is a cost-effective solution where once we found one value, we can just simply flip the sign and get the other one. But in case anyone still not too convinced about the method I went here, then think about it. I still have some little space here, and we can restart completely from scratch for finding out how Z2 is. So left area of Z2 the way how this picture looks, it's all that area here added together with this little piece. But think about it, if we're starting out with Z2, in case we're starting out with Z2 as a beginning independently without finding out where Z1 is yet, or how far that area to the left of Z1, then think about from where this curve center is. All that area to the left is already 50%. So 50% is all this area from the center that way. But now the total accumulated area to the left of Z2 has to be accumulated together with this much area here. And so in that way, I'm going to add with half of the 80. So 50 plus 80 over 2, which gives me so the total area shaded to the left of Z2 is 90%. And like I said, my explanation here is just one explanation of mine right there. It might not be the best explanation for somebody. It's okay. You have your own. Take it. This problem is really meant to be finding how big the area to the left side of a given z-score. Once some information already given, it's quite simple. So you don't have to only believe in my solution here to find the left area. The bottom line now, or the rule of thumb, is to find the left area, some left area, before we can find out what z-score that is. And so now my left area here for Z2 to the left of Z2 is 0.9. And once again, there are plenty of technology or technological resource out there so that we can invert an area and to come back with a Z right here. And so here I designed my program INVZ, and I'm going to use it for my own convenience. And so the INVZ running on top of that given area being 0.9, and Z2 is here. And so now if we're doing the calculation, and once again back into my INVZ program, so 0.9 is the area, and now if I hit enter and look at the result right here, and again on the TI-83 or 84 calculators, this is how we do to get the exact results. As we have seen, we go second, variables, and once that distribution menu is brought up, we're going to select option number 3 that says INV norm. It's a command, it's a program. Hit enter. TI-83 or earlier 84 calculator, instead of seeing menu, you are going to be taken directly to the command being printed on your home screen and ready for you to type in your area value along with a comma, 0 and 1. And so for the newest TI-84 calculator, this time we are going to type 0.9 and hit enter, and again, as I said, we are going to leave these two values defaulted at 0 for mu and 1 for sigma. So I'm going to hit enter to skip these a few more times, and now we arrive at that INV norm command being completed with the 0.9 as our area to the left of the designated z-score, with a comma, with a 0, with a comma, with 1, and with a closing parentheses. And now we are going to hit enter. And this is the exact z-score that we have seen calculated from the INVZ program. And of course, in the far run right here, so Microsoft Excel somehow they're rounding it slightly off right here, but technically speaking, it is the exact opposite value of negative 0.28155516. So it's just exactly the same with that.